I was thinking the other day, are our shiny new AI coding tools really helping us? Or are they just helping us write bad spaghetti code, but like at a much faster rate? I mean, we're generating lines of code faster than ever before in human history. But if we haven't actually solved the underlying process issues, aren't we just scaling our technical debt?
Welcome to today's Explainer. We're going to unpack exactly how a concept called AIUP is changing software development forever. We're diving into the AI unified process, which is essentially this ultimate antidote to all that AI-generated chaos, and it actually puts control firmly back in your hands. So, here is our roadmap for today. We'll look at the code-centric problem, the AIUP paradigm flip, specs as living artifacts, the layers of AIUP, and finally some real-world results.
Let's jump right into Section 1, the code-centric problem, or why traditional development falls short. We've all felt the pain of working on legacy projects, right? Traditional software development is just overwhelmingly code-centric. And what does that actually mean in the real world? Well, it means your requirements get outdated the absolute minute a developer starts typing. The documentation, it naturally drifts away from reality. And then, when bugs inevitably pop up months later, what do? We have to dig through the source code itself just to figure out what the system was actually supposed to do in the first place. In this old model, code is literally the only reliable source of truth. And man, that creates an absolute mountain of technical debt. And here's the modern trap. AI coding tools are actually making this specific problem a whole lot worse. Think about it. If we just throw standard AI agents at a broken, code-centric process, all we're doing is accelerating the mess. We're generating code at light speed, sure, but without fixing the fundamental misalignment between the business's needs and the software being built. The AI doesn't magically know your business context. It literally just types faster than you do.
Okay, moving to Section 2, the AIUP paradigm flip. This is all about shifting the source of truth. We really need a completely new paradigm for AI-assisted engineering. In traditional development, the process is super developer-centric. Even when we use spec-driven tools today, those specs are honestly just elaborate throwaway prompts. You write them to get the code, you toss them out, and the code remains the source of truth. But the AIUP paradigm flips this entire thing on its head. It is requirement-centric. The specs describe the behavior of the system, and that behavior becomes the absolute source of truth. The code? It merely serves the spec. It's just a generated implementation wrapped around your defined behavior. It's a total game changer. Which brings us to Section 3, specs as living artifacts, going way beyond throwaway prompts.
Let's clearly define what this actually means. Spec-driven development is a methodology where specifications describe the behavior of a system rather than the code doing that. These specs act as first-class, living artifacts that are actively maintained by requirements engineers. This is a massive philosophical shift for sure. It basically means the core requirements knowledge must never leave the team, even if the underlying AI-generated implementation completely changes tomorrow. The spec is essentially your real product now.
So, let's break down how this works mechanically. Specs capture what the system must do, never how it does it. AIUP relies heavily on proven methodologies like Use Case 2.0 and 3.0, meaning use cases serve as your fundamental unit of work. Every single change request to a running system, whether it's a bug fix because it's doing something weird or a brand new feature, is handled systematically and traced right back to a clear business reason. And because of the structured approach, the spec outlives any specific code implementation.
All right, Section 4, the layers of AIUP, or structuring the methodology.
One of the most common questions we get is, well, where does the spec end and the AI implementation begin? The answer is broken down into 3 distinct layers. Step 1 is the what, so that's the specification, the use cases you define. Step 2 is the harness. These are the tests that validate the behavior you just asked for. And Step 3 is the how, the actual code implementation. In the AI unified process, you and your team control the what and the harness, and you let the AI handle the how.
Managing these layers relies on a really robust framework. AIUP utilizes 4 agile phases and supports 2 primary workflows: greenfield for your brand new projects and brownfield for modernizing existing ones. But the absolute magic here, it's the test-driven consistency. This is what enables safe refactoring. Because you're working in these iterative cycles of requirements, code, and tests, your teams can safely evolve software in parallel. I mean, it truly doesn't matter if the AI completely rewrites the how layer tomorrow because your test harness guarantees the system behaves exactly as the spec dictates. It's just brilliant risk management. Let's look at Section 5, Real-World Results. This is where developers are finally taking back control. I want to share some real-world validation to prove this isn't just, academic theory. Take a look at this quote from Mark Affolter, a senior software engineer. He says, "For the first time in agentic engineering, it felt like control was given back to me, a feeling I had missed since leaving the AI prompting phase and venturing into vibe coding." That is incredibly powerful. AIUP cures that frustration of aimless vibe coding by giving developers a structured, highly effective framework that actually works for both fresh builds and messy legacy codebases.
And it works beautifully at the enterprise scale, too. Jens Kreitzer, a team lead development, noted, "With requirements and use cases consistently at the center, we stay in full control even in an established codebase. The subsequent implementation was surprisingly fast." This testament really highlights how efficiently spec-driven development scales. When you're evolving existing, highly complex enterprise products, you never lose the plot because the use cases are always your anchor. The AI just speeds up the implementation of those anchored ideas. Plus, this structured approach builds immense developer confidence. Nick Bocher built cross-platform Rust apps and shared this experience. Writing specs, implementing and testing together with Claude Code. Cool stuff. And afterwards, you actually understand what the code does. Think about how vital that is. Instead of treating AI output as this terrifying black box that you're too afraid to touch or modify, you actually understand the resulting AI-generated code because you explicitly drove its creation through your own specifications. And let's talk about sheer speed and leverage for a second. IT consultant Bjorn Wilmsman shared his story. "With AIUP and spec-driven development, I shipped a complete product in 3 calendar days, with maybe 4 to 5 hours of actual work. Literally. He took a 2-sentence README, generated formal requirements and use cases from it, and had the AI handle all the tedious implementation, from OAuth to API integrations without a hitch." That is the true power of how AIUP is changing software development.
So we arrive at the ultimate question for everyone watching. If AI is going to write the actual code from here on out, are you ready to become a requirements engineer? The AI unified process proves that our future value is no longer in typing syntax, but in strictly defining system behavior. I highly encourage you to reflect on what this paradigm flip means for your own career and your daily workflow. Thank you so much for joining me on this explainer. I hope it sparked some great ideas for you, and I'll catch you on the next one.